Hello and welcome to Skynet Today's Last Week in AI podcast, where you can hear us chat about what's going on with AI. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I am Andrei Kurenkov, one of your hosts. I finished my PhD focused on AI at Stanford earlier this year, and now I work at a Gen AI startup in Silicon Valley.
And I'm Jeremy, I guess the other host here, and I'm the co-founder of Gladstone AI, which is an AI safety company. We do a bunch of technical AI kind of alignment research, stuff like that, and extreme risk policy work. And yeah, if I sound a little bit different, by the way, I'm not in my usual rig with my usual setup. So I apologize if the audio isn't quite as wonderful as I would love for it to be. But it is nonetheless great to be here, Andre. We have a really, really intense week of news.
Yeah, this time will be a lot of research to cover, so we'll try and get through all of it. And as usual, there's quite a few little iterations on apps and things you can use, so those will be pretty fun. Before we get into it, we want to address some listener comments. In particular, there was an email with someone asking if there is a sort of TLDR version of this usually very long podcast, which is understandable. So we do have a text newsletter that you can sort of just browse real quick for all these stories. And we are pondering creating TLDR episodes using AI. Just take the transcript, summarize it, do some synthetic voice generation. So we were thinking about it. Let us know if you would like a TLDR version of like a 10-minute summary of the highlights of each episode. And we might start putting those out. We'll see. We also haven't gotten too many emails or Apple reviews lately, so do feel free to email us at contact@lastweekin.ai with any thoughts or suggestions or corrections, and feel free to leave us 5 stars in case it helps people discover us. I don't know if it does.
I actually, by the way, I had a call with a listener a couple of days ago, and it was, this guy's a lawyer, and he pointed me to a story that I had not been following on the legal side. So shout out to Mike Justice, and we'll be covering that story. I thought that was really cool. It's a rare pleasure to be able to talk to people who actually listen to the show.
Yeah, and story suggestions, things to cover, are also very welcome. We've had a couple emails with highlighting of stories that we did cover, so feel free to send us that as well. And let us go ahead and get into the news with our first section, Tools and Apps. And the first story is Reka launches Yasa-1, a multimodal AI assistant to take on ChatGPT. So Reka is an AI startup founded by researchers from DeepMind, Google, and Meta. So pretty strong team. And they, have launched this multimodal AI assistant, which is essentially what ChatGPT-4 is. It can understand images, short videos, and audio snippets. So it's actually a little more multimodal than ChatGPT. It can be customized on private data sets of different modalities. It supports lots of languages. It can provide answer with context from the internet, process long context documents. So it can do a lot. It's actually quite an intriguing new chatbot that I could see potentially being more useful than ChatGPT for some applications.
Yeah, and this is a really interesting play. I often talk cynically about the prospects of companies that haven't raised much money, that can't muster the kind of compute resources that like a OpenAI or DeepMind can muster. I think this is one of those cases. Reka's only raised about 58 million, something like that, in their Series A. A lot less than that in their seed, obviously. So it's a very kind of funding constrained team right now. And they raised that money back in June, so that they're not flush for cash right now. So that immediately places them in a fundamentally different class from OpenAI, from Anthropic, from DeepMind, from even xAI, which is stockpiling huge amounts of GPUs. And so the question then becomes how do you compete if you can't pre-train a model? If you can't train a model that has the depth of kind of world knowledge that a GPT-4 has, how do you how do you compete? What's the axis that you choose? And it seems like the axis they're choosing here is, oh, well, we'll just be more multimodal. We'll offer you a greater kind of, let's say, breadth and less depth. This may be one way to think about it. They seem not self-conscious about this, more like self-aware of it. One of the things that their company statement said is, we're proud to have one of the best models in its compute class, but we're only getting started. Right. So this is implicitly an acknowledgement that, like, we're not competing directly with GPT-4. We're not competing with true frontier models, but we're making this very interesting play. And I think this is really one of the few plays that you have left if you're going to try to compete with the GPT-4s of the world, the Palm 2s, the Geminis, and stuff like that. So really interesting to see what Reka's up to here. This is really cool. What they're describing as capabilities is more than I would have expected at this scale. And that surely reflects the capabilities of the team.
That's right. This is currently in private preview, so you are not going to be able to use it. It is going to be available via APIs for some enterprise users, so we can see it, powering products. And as you said, really, you can't do this with existing APIs. So for things where you need audio or even image explanation, this might actually work better. And they do also note that they trained Yasa-1 from scratch, including everything, which is pretty impressive. And it does go back to a funding question, because training ChatGPT from scratch costs, I think, tens of millions of dollars. Like, it's a big task. Yeah. So it is very possible that this is smaller and perhaps even has less training data, because that's another bottleneck for doing things from scratch. But definitely a company to keep an eye on.
Up next, we have Arc Browser's new AI-powered features combine OpenAI and Anthropic models. And so this is the Arc browser, which, to be honest, like, I'd never heard of before. So this is kind of interesting to read about. They're launching a new AI-powered feature, or a set of those features, called Arc Max. And this is a combination of OpenAI's GPT 3.5 and then Anthropic's models, presumably Claude and potentially others as well. There are a bunch of kind of little capabilities, a bunch of individual little features that are kind of cool in here. It's essentially kind of part of that theme of integrating AI and chatbots more and more into our everyday experience with software, in this case, the browser. But you can think of it philosophically as an extension of the Microsoft Copilot strategy, where, all Microsoft products just have this infused. And so one of the things you can do is you can have it rename downloaded files based on the content that they contain. I really like that, because that's something that, I find frustrating when I download papers from the archive. Andre, I'm sure you've seen this, with the really obscure numbers and stuff. Yeah, this is really big help. If I look at my downloads folder right now, it's just like all this crap, right? So it would be great to see that. And then, you can also do things like grab a summary preview of a link when you hover over the link and press Shift. And then they've got a bunch of hotkey things. If you could hit Command T, that kind of brings up this Arc Max command bar, and you have a whole bunch of capability over choosing which features to enable. So sort of interesting. There's a lot here in terms of what AI can do when integrated in the web browser. And it's also an interesting new distribution channel for Anthropic and OpenAI. And one of the things I'd be really curious about is to figure out what went into the decision of where to use GPT 3.5 and where to use the Anthropic models, because that's a really interesting dimension. Why mix and match these models, and what implications do those choices have? So kind of cool story.
It is pretty cool, and it's interesting to see these slightly different uses of chatbots. We've seen it be sort of, you have a built-in chatbot in the sidebar or something like this, but this is really integrated into base functionality of a browser. One I like quite a bit is also this Ask on Page feature. Apparently, when you press Command F to search for words in a page, which I do a lot, that I guess is often used by many people, if you cannot find the word you're looking for, then this ArcAI can find an answer for your query in the page rather than just look for a word. So that's pretty nifty, and it'll be interesting to see if these sorts of things will just generally be coming to browsers as extensions. The company did say they experimented with various features and are going to be collecting feedback and data going forward. So they may revise these kinds of things. Yeah, it's a nifty kind of implementation of the assistants, and we'll see what else they do.
Yeah, it's also especially interesting to see the fact that this isn't just a chatbot integration. More and more, we're seeing product and AI kind of overlap and integrate more deeply. And I feel like it seems like a more realistic path to real value generation. Like you're not just like launching a chatbot and having the chatbot do everything. You're doing things like thinking about, okay, what are people hovering over, and what AI assisted tooling can we add to the hover function? Things like that. I think that's kind of the next level of product design, product management probably is going to look a lot more like that. It's like the very handcrafted use cases that are carefully studied, rather than just like, let's slap ChatGPT or whatever in our app for some reason.
Exactly. Yeah, I think it's similar to G Suite or all the Microsoft products where AI is just part of a product rather than the product, right?
Right.
On to the lightning round, with our first story being ElevenLabs launches voice translation tool to break down language barriers for content. So ElevenLabs is kind of probably the leading startup for AI for voice applications. They have very impressive, pretty much cutting edge voice synthesis technology going from text to voice. And now they're featuring AI dubbing that can convert spoken content into another language while preserving the original speaker's voice. And we've seen this with YouTube. I believe they launched this feature to redub your video in another language. And we've seen this with some like musicians, even, where they retained the performance, I think, for K-pop. So I think this will be a kind of new norm where for content, we'll just have various versions for different, demographics. And I guess that's good, right?
Right. And I think one of the metrics to keep an eye on too is this idea of the lag, how much time it takes to generate these dubs, just because you push that further and further, you're unlocking more and more use cases. And eventually you get to the point where, you can do real-time dubbing in a person's voice. And that gets really exciting from just a translation standpoint, right? The natural flow of dialogue conversation. So interesting to see how as the processors get better and better, as the models get more and more efficient, compute efficient, maybe we can start to flirt with that too. And that would put ElevenLabs on a really interesting trajectory as well. So kind of cool to see this pop up. Cool to see 20 languages covered. That's no small feat given the availability of data in some of those different languages. So yeah, really cool next evolution for ElevenLabs.
Yeah, some of these languages include Hindi, Portuguese, Spanish, Japanese, Ukrainian, Polish, and Arabic. So, many of those are very widely used. So it is neat. And once again, ElevenLabs putting out pretty impressive stuff.
Next, we have Canva's new AI tools automate boring, labor-intensive design tasks. So if you haven't heard of Canva, they're, I think, an Australian. Are they Australian, New Zealand? They're Australian or something in that neck of the woods company. And they do graphic design, and they help people make social media graphics and presentations, that sort of thing. And they have a suite of now AI-powered design tools. And the idea is to make it really easy to transform designs into different formats. So you can think about converting a blog post into an email or a social media post without having to do any manual changes. And this is like absolutely in the butter zone, right, of language models today, essentially just translating text or content between different media. It's a form of summarization in a way. It's a form of translation, depending on philosophically how you think of it. But this new feature is going to be called Magic Switch, and that's what it allows you to do, is switch between these different, like kind of toggle between social media, email, blog, those sorts of things. They also have a Magic Media tool that includes now text to video capability. We've been talking about that for a while, right, on the show. We've seen text to image for a while kind of come into its own and really mature. where the next evolution, just with compute becoming more abundant, that's really the only thing holding back text to video at this point, is more compute efficiency and more efficient algorithms, but the fundamental ideas are all there. So I think the next year and a half to 2 years is going to be the story of sort of the mid-journey moment for text to video, and it seems like Canva's already kind of sniffing up that tree. What I don't know what the hell I'm trying to say, but they're on it.
Yeah, they're moving towards it, and that one is powered by Runway AI. So I think as Runway improves it, and they are the leading kind of AI for video provider, so that actually makes quite a bit of sense in that collaboration. And yeah, I think there's quite a few interesting notes here. For instance, Canva has also announced that it will pay out $200 million over the next 3 years to designers who consent to having their content be used to train the company's AI models. And so far, they haven't been trained on that data, and there is an opt-out option up front if you don't want that. And otherwise, they'll be opting in by default, but very explicitly. So that's interesting, and in many ways mirrors Adobe, right? In general, what they're doing. Right. They're doing kind of image expand. Apparently, Adobe also announced a similar compensation program for Adobe stock contributors. So I think it's generally interesting. In a way, it feels like, this year has been crazy with AI moving so fast and just showing up everywhere. And as we've been covering, it feels like more and more there's kind of a playbook emerging of how to do things right. You want probably legal indemnification. You want to say, we have safeguards in place, and you can use our AI features without worrying about legal repercussions. You want to be very transparent about training on the data of users, and things like that. So pretty impressive progress by Canva, and I guess this does seem like an alternative to Adobe if you need these kinds of AI features in your workflow. And speaking of Adobe, we have a small little feature that they're presenting. Adobe previews AI upscaling to make old fuzzy videos and GIFs look fresh. So this is an experimental AI-powered upscaling tool called Project Resup. That's pretty cool. And it's using AI to upscale things. So take, something like a low resolution GIF or video and make it way higher res. Like they have an example here of taking a clip from a 1947 movie and upres it from 400 by 360 pixels to 280 by 960. So that's a huge upres. You've seen this be done, with AI before. It's kind of one of the very natural uses of AI. But again, showing how Adobe is very rapidly building and releasing these sorts of AI features.
Yeah, the pace of release with Adobe has just been pretty remarkable. And also, we talked about their leadership. You alluded to it earlier with this idea legally of indemnifying people for using Firefly, their image generation service, and saying, look, if there's a copyright violation that emerges from this that you're exposed to, we will indemnify you. We will help protect you in court. So they've really been aggressive here in pushing the envelope. It's kind of an interesting capability in a weird way. Like, it makes me wonder what's going to happen to cameras. We're already obviously seeing this kind of tech embedded in the iPhone, as it does super resolution, as it's called, on regular everyday photographs. But it makes me wonder what the impact really on the camera market is going to be. And also, like, you can imagine some kind of interesting snafus where some embarrassing detail is not caught on a lower resolution film or whatever, and then when you upsample, you start to see stuff. I don't know, private information, things like that that people didn't realize was available. I'm kind of curious about whether we're going to see some like little amusing tidbits like that we might not expect. But other than that, it seems like a generally interesting story and a capability that I think a lot of people are going to use.
Yep. It's still in this experiment phase, so there's not even a beta option, but it probably will wind up in one of their video or image editing tools. And it just reminds me actually to just mention, right, upscaling has been around. This is just a particularly impressive version of it. And if you haven't, you might enjoy going on YouTube and looking at some examples of this, of like people have done this colorization and resolution of videos from like 1910 or like super old videos of San Francisco from 1920, and it's pretty crazy to be able to see these videos of like old timey cities and settings, and they look pretty pretty modern with all this stuff, and it really is cool to see.
Yeah, actually, to your point too, for people who are wondering like roughly how it works, because Andre, you mentioned that it's like this very natural application of machine learning, and part of that is just how the data works here, right? So you imagine taking a photo and artificially reducing the resolution of that photo, which is quite easy. Average together the colors of like the 9 closest pixels or whatever, and then you basically teach the model to take the grainy input and use that to predict the original photo, and you do that over and over again. The model eventually learns like what are the how do you do that super resolution kind of function. Which anyway, sort of interesting to see that get productized in the form of videos and GIFs. Which again, videos, we're there now. And up next, we have Google Bard is gaining a new memory toggle to remember key details. So essentially, this is, we're used to interacting with these chatbots and giving them some information about us, which they hold in memory for a time. But then once you close the window and you close your interaction with Bard or ChatGPT, obviously the model forgets everything you told it. It has no context on you that it can reuse for next time. And this is an attempt to counteract that. So essentially, you're going to be able to give Bard some facts about you. And the examples they give are, I try to avoid eating meat. I have 2 kids. Please give shorter responses. I like shorter responses. And Google will kind of store those in memory and then use them to sort of customize Bard a little bit more. And I think that's really what this is fundamentally, is a customization play, trying to make Bard more personalized, more custom to the particular personalities and needs and life situations of all their users. And it doesn't hurt that they're collecting some really interesting data in the process, right? You think about the kind of data you're going to prioritize to store in memory here for Bard. I think it's going to be pretty interesting, monetizable data. So seems like a kind of good deal for Google and maybe for early users.
Right? Yeah, ChatGPT launched sampling this, I think, a month or 2 ago, where you can basically say, for all my prompts, have this in the context. So now it's coming to Bard as well. And that seems useful if you have a very particular application, like, I am a school teacher and I need help with this or that. And also, speaking of Google, they had an announcement about Assistant with Bard. So they have had their Google Assistant for a while. That's their Siri-esque thing. You can talk to it and ask it to do stuff. And they said that it will get an upgrade where it will have Bard integrated. So then you can interact with this assistant through text, voice, images, etc. And as you might imagine, the assistant will be much more capable at interpreting your queries, answering queries, etc., etc. Very natural, kind of logical thing to do, I guess, with an assistant, but we haven't seen it be done with Siri or something like that yet. So this will be pretty cool if you like this sort of assistant feature.
Yeah, one of the things I read in the blog post that kind of gave me like existential thoughts was they were saying like basically imagine that you take a photo of a cute puppy and you want to post it to social media. Just go to the assistant with Bard with the Bard overlay and ask it to write a social media post about that dog picture for you. And Bard is going to just like use the image as a cue, understand the context, and like produce this post. And they show an example and it's like, oh my God, such a cute dog, like emoji, all this stuff. And I'm just thinking like, oh my God, like is this a social media is going to become like, you're just seeing a bunch of like AI generated crap. We're not even bothering to like write what we think about the photo. We're just like letting Bard express. Anyway, that was sort of, I don't know if it made the point that they wanted to make, but that's how it landed with me at least. They are rolling it out with early testers soon, so they're certainly not done here. They're getting early feedback before they bring it to the public, and that'll be over the next few months.
last one for Google, I guess we covered a few features that they're saying. There's a neat little thing that will come with Android 14, which is AI generated wallpapers. And that's pretty much what you can imagine for your wallpaper for your phone. You can now use text to image right in Android to generate whatever you want. It will be coming first on Pixel 8 and Pixel 8 Pro, but it should be on, I guess, all Android devices upgraded to Android 14 pretty soon.
Very cool.
And moving on to applications and business, with our first story being Waymo's robotaxi service is now available to tens of thousands of people in San Francisco. Waymo is expanding the service, which has been running for quite a while in a sort of closed waitlist capacity. And now it's covering more of a city, 47 square miles, and allowing, again, tens of thousands of people to access the service. And this is essentially like an Uber, but with robotaxis. So you hail a car to pick you up and take you somewhere, and there's no driver in the car. And in fact, I happened to have used it this last Sunday. Yeah, when I was in SF.
You would never become part of the story.
Well, too late. But I can tell you, yeah, it's pretty nice. I liked it a lot. It's pretty much what you would expect. And from everything I've read and seen, it seems like, aside from perhaps being a little bit overly cautious, sometimes it's a smooth ride. It hasn't gotten to any crashes. And I guess this will be finally a source of revenue for Waymo after like a decade or something of working on this.
Yeah, and they were saying $1.1 billion spent over the course of that decade too. So this is, not chump change. I'm curious though, from your experience, you mentioned it's a little bit cautious. What are some of the ways the cautiousness manifests? Like, is it when they're pedestrians, or is it changing lanes, things like that?
Yeah, there's cases of, for instance, some of these like more intuitive things of maybe a pedestrian starts to cross, but then stops a quarter way in to let the car pass, right? And the car will do the legal thing, which is to wait for the pedestrian to cross, even if legally, or even if like logically you would typically go ahead and pass, things like that. Although at the same time, I will say it's less cautious than you might expect. So it's good at taking initiative in a way that you would want. It's not like, oh, if there's a car coming very far away, I'm going to wait forever and then go. It knows when to go a bit faster to overtake and do things like that. So yeah, it's actually a pretty good ride. And if you live in San Francisco, you can, I guess, go ahead and give it a try. And soon that will also be the case for LA and other places.
Right. Sorry, I'm so curious about your experience on this. I just one more question there. Did you find that pedestrians or other drivers seemed more on edge once they realized? Did they realize it was a self-driving car? Like, is it outwardly obvious?
I don't think they were on edge, but it's interesting actually. A lot of pedestrians kind of found it fun too, or like they found it interesting. There were people like taking photos and videos of these Waymo cars.
Oh, wow.
It's at one point we were driving on like a empty street, and these two pedestrians stopped in the middle of the road to just mess with the car, and I had to like shoo them away so I could keep going. So I think it's still definitely a novelty for people and interesting. And yeah, I didn't see anyone be nervous, but I would imagine some drivers might be.
Well, because they do look weird as hell, right? I mean, like every time I go to San Francisco, I'm still not over it. You see the because they have the twirling LiDAR stuff. They got the big rig on top. Anyway, it's a bit of a monstrosity, but hey, it works.
And there's no driver up front. Yeah, if as a driver you see that and you're like, whoa, what? But yeah, it's pretty well designed. So there's like an assist me button right up front. So if you do get stuck or it does something weird, you can, I guess, call Google, and I would imagine someone takes over that's a human and makes it do the right thing.
Up next, we have GitHub Copilot loses an average of $20 per month per user, or per user per month. Same thing. So we have GitHub Copilot, which is charging users $10 a month. They're losing, on average, $20 per month, it turns out, according to this report. And so that means essentially, it costs like $30 per user per month to run, that's also oddly close to what Microsoft charges folks for access to Microsoft 365 Copilot, which is $30 per user per month. So that really all indicates the insane expense of, not just training the powerful models that are used to run these services, but just running them, doing inference. Like most of the cost now is in inference for these systems. Andre, you just mentioned like tens of millions to hundreds of millions to train these systems. Well, the cost to do inference, right? We're now in multiples of that. So pretty wild, and a big business risk. We're starting to see Microsoft pour money into this, and obviously GitHub and OpenAI, Google doing the same, effectively subsidizing our searches. And sort of like Uber back in the day, right? They were subsidizing rides. They were not profitable the vast majority of their lifetime. The question looms, can you turn this around? Can you actually make a profit on this? And what's the relative value of capturing market share, which is what they're doing. They're prioritizing capturing market share by essentially discounting the price artificially, versus actually turning a profit. And the fact that that's not even being attempted, the fact that these companies are okay taking such a huge loss, and these are really massive scale losses, suggests that they think there's a lot more leverage in the future in just taking the L, like bleeding the money for now and just growing that market share, getting people used to using their product.
Exactly. Yeah, this is quite interesting. I think for one, because this is GitHub Copilot, which we don't have concrete numbers, I don't think, but I would imagine has at least hundreds of thousands, if not millions. Actually, they do say more than 1.5 million people have used it. And that's a lot of users to be losing $20 a month for, right? And I think it is particularly hard in the coding context because usually, right, the cost is per token. So it's every time you generate a character or a couple of characters, it's maybe like 0.0004 cents or something. But in coding, what happens is if you have this enabled, anytime you stop typing and you press enter, it will give you a suggestion, a suggested autocomplete, and you can use it or you cannot use it. But right, when you continually make suggestions every time, those add up quickly. You generate a lot of text, and I know a lot of boilerplate code, which is write me a get function. Well, that's, I don't know, 50, 100 characters that you have to pay for. So yeah, it's very interesting to see this report, and it'll be interesting to see if and how Copilot can actually handle this. We've seen for image generation, it's very typical to have a limited number of generations per plan, and then you can buy tokens. For instance, DALL-E does this, where you have to buy kind of image credits to spend. And I would not be surprised if that's something that this kind of tool will move to.
And moving on to our lightning round now, we have, AI hardware time. TSMC sales fell less than feared as AI demand offsets slump. So TSMC, we've talked about them quite a lot on the show. They are basically the world's most advanced, most capable manufacturers. It's a semiconductor fab factory. So they make semiconductor chips. And these are the chips that, among other things, go into leading edge AI GPUs like the NVIDIA H100 that's gotten so much attention. But they also make stuff, their 3 nanometer node goes to the iPhone. They've got, kind of really, and that's the absolute bleeding edge, right? 3 nanometers is the smallest node size that human beings know how to make on planet Earth. Then there's the 5, which is used for the H100, and there's the 7 nanometer node size, which is the A100, the predecessor to the H100. And then there's a bunch of bigger, kind of sloppier node sizes, the 14 nanometer, for example, that get used in more mature systems. And one of the big questions has been, look, we're seeing a slump apparently in revenues for TSMC across a lot of their different, chip markets. So looking at smartphones and laptop chip sales in particular, and maybe this has to do with rising interest rates internationally and decreased consumer demand. I don't know, but that may be part of it. The hope, though, has been, well, maybe this whole AI hype thing is going to drive demand for AI chips, and that'll offset some of the losses here. And that's exactly what seems to be happening. The preliminary sales numbers have just kind of come in, and it seems like indeed data centers are driving this, AI data centers, that is, are driving this increased demand for these chips, in particular NVIDIA chips and the memory associated with those chips. And right now people kind of all eyes are on this stock because they've got a new report coming in on their earnings for July to September on October 19th. So as we speak, about a week away. And so it'll be interesting to see what happens. Does this actually come to pass? Is the AI hype bubble, is it a hype bubble, or is it just like an actually profitable source of revenues, among other things, for the hardware sector, for the chip fabs like TSMC?
And on to more hardware stories. For instance, Microsoft could debut its AI chip next month. So this is, speculative-ish, but seems pretty safe to say that Microsoft is reportedly planning to unveil its first AI chip at its annual developers conference, which will reduce its reliance on NVIDIA-designed chips. And we've seen this happen with other companies. Google had their TPUs. I think Meta had custom server racks, which I don't think were custom chips, but were still custom hardware. Tesla has custom chips for their AI for self-driving. So and now that we have this kind of demand bottleneck, the ability to get chips is hard. It seems like Microsoft is very much intending to debut their own type of chip.
Yeah, and this is really a recurring theme that we're going to see today, and I think over the course of the next few months, as companies like Microsoft really, really try to artificially pump up competition to NVIDIA. There are deep strategic reasons, and one day we'll do an AI hardware episode, I'm sure, but there are deep strategic reasons why that's like NVIDIA's uncontested dominance in AI chips is just really, really bad for the likes of Microsoft, for the likes of Google, OpenAI, not just because they have limited supply of chips. It's always good to have more players, but also because you can't negotiate in the same way when you've got this absolute chokehold on the space. And one of the strategies that Microsoft's been exploring, yes, is designing its own chips. It's also been exploring partnerships with companies like ARM to try to work the software side of things, kind of build out an ecosystem of software to compete with CUDA, which is what NVIDIA essentially has their moat built on. It's so easy to use these GPUs because NVIDIA has been refining the CUDA ecosystem for so long. This is all going to be part of, I think, again, the story of the next few months, and a really, really critical unsung part of the kind of whole AI global competition angle.
And adding to that, it's very much the case because ChatGPT-owner OpenAI is also exploring making its own AI chips. So this is reporting on internal discussions in the company. And it's pretty much the same as Microsoft. They are dealing with this crunch for hardware, especially as they commercialize and are offering, their API to enterprise customers. So it's, kind of the same story. They are thinking about developing their own chips or acquiring a chip company.
Yeah, and really surprising to see OpenAI doing this, just given how hard it is to make these chips, right? I mean, it's like, roughly speaking, it's like $500 million to even get into the kind of the initial lift of designing your own chips. So for OpenAI to be considering this it's quite fascinating. I think it reflects the fact that they've kind of started to mature into this wildly large valuation, $70 to $90 billion. We're starting to see them make $70 to $90 billion moves. And one of them is, thinking about designing their own chips. Again, these are internal conversations, so it's all kind of rumor mill stuff. But one of the things that is being claimed here is that OpenAI has considered this option to the point where it's actually performed due diligence on a potential acquisition target. So this isn't just some idle kind of banter over beers or whatever. This is a strategy that they're exploring quite intently. I think it's fair to say if OpenAI does this, I mean, they're going to be the smallest by headcount model developer company that's designing its own chips, and that'll be really interesting. Again, really tough area to break into. Even Meta's had custom chip effort that's just absolutely flopped, at least so far. There've been a lot of problems there. They may well succeed. They likely will eventually, but this is no small task. And OpenAI taking it on is or potentially taking it on is a really interesting data point in terms of where they think the strategic leverage is going to come from in this ecosystem.
And on to the last story for this section, more on the applications front. Google announces new generative AI search capabilities for doctors. So this is Google Cloud, and these are AI-powered search capabilities broadly for the healthcare industry that allows doctors to access and search for clinical information from various types of medical records in one place. And this is something I think that I've been working on for a while, generally applications of healthcare with Google Cloud. And this one is aimed to save time for healthcare workers who often spend a ton of time working with these medical records and trying, using various tools, etc. So yeah, it's hopefully going to make it easier for healthcare workers to not face burnout. And on to our next section, projects and open source, starting with Replit's new AI model, now available on Hugging Face. So Replit AI, which is focused on code completion and code assistance, is now free for all users. They've released their Replit Code v1.5 freebie, 3 billion model on Hugging Face, where you generally release your AI models for download to anyone. So this is now an open source language model. And I think this points to something interesting we've been observing more and more, which is industry being the driver of open source. It is expensive to train these models. It is presumably advantageous to have the better models compared to competition. And yet again and again, we've seen big players release their models for anyone to use with permissible licensing. So yeah, this is another example of that.
Yeah, I'm really curious if this will persist. If we'll keep seeing, because at a certain point, you start to wonder, okay, what is the marginal value being added to the open source ecosystem when we have like yet another model that isn't, if it's not like the next like Falcon or the next Llama that really pushes the envelope. You sort of start to wonder, okay, like is this worth effectively just the headline? Because at a certain point, that's what you get. Obviously, there are marginal benefits to going with one model or another, but the reality is, as somebody who develops with these systems, like I kind of just get confused about where I should even go. Like it's just so time consuming to figure out which model to use that you end up going back to your kind of your stable of preferred models and things like that. You might go to a leaderboard, but then you're usually looking for the extremes, a model with really low latency that can give outputs really quickly, or you're looking for a model, like GPT-4 that's really, really good, or like Llama 2. So ultimately, I kind of feel like there's going to be an interesting question, and we'll see this resolved maybe over the course of the next year or so as to what the value really is for these companies putting out these open source models, again, beyond the headline, because they are getting attention from this. That is something that allows them to be seen as like a player in the open source community. And maybe that's enough. But as the cost of these models kind of tracks upward, as more and more is expected to be relevant and to earn those headlines, I think, I don't know, it'll be an interesting question to see answered.
Right. And it's actually important to note that this was done alongside a general product announcement, which was Replit AI for all. So it sounds like they've been working on developing the infrastructure, the compute infrastructure, to be able to offer their AI features to everyone. And now they say that code completion and code assistance are now enabled by default and available to 23 million developers. And developers on the free plan will have access to the basic AI features, while pro users will have the exclusive license to the most powerful AI models. So I guess the moat, as we've discussed before, might be on the infrastructure front more so than the actual models. And we'll see. We just talked about Copilot losing a lot of money. Maybe Replit will figure it out. I don't know.
And up next, we have, it feels like deja vu, introducing Stable LM, a 3 billion parameter model, building sustainable, high-performance language models to smart devices. Now, this idea, yet another, yes, language model. Again, yes, at 3 billion parameters. One of the trends that we absolutely are seeing is companies starting to focus in, especially in the open source, on smaller models. Smaller models, yes, are great because they are cheaper to train, right? So you have essentially you have fewer parameters that have to be tweaked during the training process, which means there's less actual optimization power, less processing that needs to go into the training. And that's a huge money saver. And in many cases, it's the only thing that allows these companies to compete really in this environment. They can't build a trillion parameter model to compete with GPT-4. So this is how you make that dent. Interesting also, though, not just from a money-saving standpoint, why are we seeing a lot of 3 billion? Well, this is something that makes it a lot easier to put on edge devices that have limited memory. So you can put those 3 billion parameters on a much wider range of devices. You can think of laptops, but also phones, things like that. So it opens up a much wider range of use cases. In this particular instance, so Stable LM, this comes from Stability AI, which is behind Stable Diffusion and that whole series of models. This particular model is being open sourced. It is just a pre-trained model. It's just a base model. In other words, it's a glorified text autocomplete system. It has not yet been instruction fine-tuned. So in other words, this is like a model where if you want to get something useful from it, you'd have to prompt it by saying something like, below is a piece of code that checks the weather, colon. And then the very next thing, it's just doing autocompletes. It's predicting what's the most likely next words that'll come. So you kind of have to do more prompt engineering to get value out of these systems. And that is why instruction fine-tuning is yet to follow. They are currently, as they say, doing their instruction fine-tuning model safety testing to make sure that it's ready for release. Unclear what that involves, but that's on the horizon. So we can expect to hear more in this direction fairly soon from Stability.
Right. And I think, interestingly, it relates to a story we covered last week, which was BTM 3B8K, another 3 billion parameter model released by another company. In this case, it was Cerebras. So as you said, I think it might be more and more of a trend of trying to develop very performant, smaller models so that you don't have to spend crazy amounts of money to have AI-powered features. And on to our last story in this section, not about an open source model, but about open source. The story is protesters decry Meta's irreversible proliferation of AI. So these protesters are essentially saying that the open sourcing of large language models that that Meta has been in particularly doing a lot of. So they've released Llama and then Llama 2, Llama 2 70 billion, very large, very powerful models, kind of on par with ChatGPT. And so, as we discussed before, there's been a lot of conversations about this with regards to AI safety, of like, if you release the models and people can easily misuse them, and that can result in a lot of problems. And this is what this article is about, in particular about actual protesters. There was a gathering outside Meta's office with people, doing a protest, having signs. There were signs of like, avoid an AI arms race, don't open source doomsday, safety over profit, don't may the genie before the lamp, no to reckless AI releases, all this sort of thing. Apparently there's even a website, metaprotest.org. So it's very interesting to see people being this passionate about this particular viewpoint, and very Silicon Valley sort of thing. But it's very much still not a resolved topic.
Yeah, I think, to be honest, like this does make a lot of sense to me, the protest that is, in that we have, we're getting to the point where GPT-4 had to be tested for its ability to self-replicate. And, we have third-party auditors that are explicitly testing for those capabilities now. GPT-4 seems to be able to help people as they do sort of early bioweapon design. It certainly can help people to design and synthesize chemical compounds from controlled chemical compounds from household materials. And so you just start to think about, apart from all the malware, like potentially catastrophic malware attacks that certainly folks at Anthropic and OpenAI and DeepMind have all warned about, and they see coming, even in the next like handful of years. And so if that's the world we live in, and if open source trails those capabilities on average by whatever it is, 6, 12, 18 months, depending on the capability, we have to imagine that, fairly soon we will have models just published freely to the open source that have dangerous capabilities. You look at Meta, they put out famously their Llama 2 and said, don't worry, everybody, it's fine. Our model has had safety measures trained into it. Well, what happens at one of the Senate hearings on the Hill fairly recently? Tristan Harris, famous for making the social network documentary, if I recall, he basically shows, hey, listen, Zuck, I just took your model with all its safety fine-tuning, and I just trained that out of the system, which I can do because it's open source. And now, it'll absolutely help me to design chemical compounds and things like all these dangerous things that it wasn't supposed to do. So the fact that the capabilities aren't there yet to do catastrophic harms, I don't find particularly comforting, given that we are, by all accounts, on a trajectory there. I don't see how this changes if we just keep on the default course. And basically everyone at all the frontier labs sees WMD level risk coming from these systems in not all that long, in a context where, again, the open source follows the frontier work fairly closely. So I think this fundamental question of is it responsible for companies to be open sourcing systems in a context where we lack the means to control them, where we lack the means to bake into them responses to stimuli that guarantee they can't be jailbroken or have safety measures trained out of them. I think it's a pretty reasonable thing. I don't know if the solution is an actual protest like this. There are other forms of advocacy, but hey, you know what? If the shoe fits, I guess go for it. But it certainly is an interesting topic, and it's one I feel fairly strongly about, just having done a ton of work in this space. But there are interesting and thoughtful critiques of this, obviously, that come from all sides. So a really important issue. I think we're going to see legislation come down on this issue in probably the next 12 months would be my guess at this point.
Right. And they were covered in IEEE Spectrum, and we did talk about them. So I guess the protest at least had some effect. True. And if you go to metaprotest.org, they have a very kind of well laid out, I guess, thoughtful, or at least clear discussion of this topic, that a lot of what you said and their concrete sort of demand, or I guess request or whatever, is not, stop Llama 2 being open source, because that's already the case. The perspective they are advocating is that going forward, Meta and other companies will adopt best practices for providing safe access to AI models, like structured access. So it's, as you said, a pretty reasonable and widely shared position. And I do wonder if we'll see even more of this sort of advocacy as we go forward. And on to the research and advancement section, starting off with robotics, scaling up learning across many different robot types from DeepMind and many others. So this is kind of a big deal for roboticists and generally robotics, which is that together with 33 academic labs, DeepMind had pulled data from 22 different robot types to create this OpenX-embodiment dataset. So with all of these different robots, with more than 20 institutions, they collected a ton of demonstrations of different skills. They have 500 skills, 150,000 tasks across more than 1 million episodes. So that's across completing a task, right? Ton of data, much, much, much bigger than any sort of data set that has existed in robotics, which has been part of the reason that robotics hasn't advanced as fast. It's just very hard to get data. Each robot is different. Each lab has their own different setup, with very different visuals and what the robot sees, the cameras, all of that. So this is by far the largest effort to collect data across all sorts of robots, all sorts of setups. And as you might imagine or hope, this has resulted in pretty big jumps in performance in some of the existing types of models. So DeepMind has already in the past developed RT1, a transformer that can select sort of high-level commands for any sort of task given a natural language query. You can think of it almost like a language model for robotics. They've also had RT2, which is similar but goes even lower level. It actually controls the robot, basically tells it like move in this direction, open your gripper, close your gripper, really going down to the lowest level of given a natural language query, what should the robot do? And it can do anything. And throughout these models, they now have RT1X, RT2X trained on all this data, and they showed, as you might hope, that with all this data, they are just much more performant and much more generalizable. So there's a lot of data here. It's a big effort. But the short version is there are on all sorts of tasks sort of jumps in 150% the performance. Like if you look at a bar chart, each one of them is a pretty big jump, twice as better or close to that. And also, really cool is that RT2X outperforms RT2 by 3x in emergent skill evaluation. So if you look at the graph, it's going from 25% success rate on emergent skills that are not in the training data to closer to 80%. So this really moves us towards this dream of general purpose robotics, which has been, kind of the frontier that is very hard to get to. Yeah, it's a big deal, and as someone who's worked on robotics, clearly, I'm pretty excited to talk about it.
Yeah, I bet, right? And the main, at least to me, the main story absolutely is that 3x increase in emergent skill capability with RT2x versus RT2. So one of the central kind of reasons that we find ourselves in the ChatGPT era, right, is that language models are able to learn from essentially like a huge number, not just of different documents, but if you think of every document as a kind of task, they're able to learn from like millions and millions of different kinds of tasks, right? They're reading legal documents and medical documents and specific kinds of medical documents about one part of the body, and they're reading about business and this and that. And each one of those things is like a separate independent task. And one of the things we seem to be learning about scaling is that task generality, that's what allows systems to, well, generalize. If you train on a very diverse data set, you end up learning not just how to do the things that you were trained for, but to kind of interpolate between them, right? To find new document types that you may never have encountered before and reason about them, because in some sense, training hasn't just taught you to be good at the specific things that you've been trained for, but more generally to understand maybe the world, to build a world model or something like that. So one of the key challenges in robotics is that, yeah, you make an arm that manipulates a Rubik's Cube. Well, you've made an arm that manipulates a Rubik's Cube. It has one incredibly specialized function. And so what I think they're doing here really is moving robotics a little bit more in the direction of that kind of language modeling type of universe where we have a wider range of different tasks. And I don't think it's a coincidence that this is where we start to see this kind of emergent capability showing up. Just like we've seen it with language models, now we're seeing it with robotics. And you might, if you're a big kind of scaling person like I am, you might expect this to just continue, right? You might expect to see as we increase the diversity of tasks more and more, this is the kind of universality of these systems, the emergent skill capabilities is just going to increase. These things are going to be able to do things that they were never explicitly trained for, because those things have maybe elements in common with a bunch of different things that have roughly been seen before by the system, or because the system just learns to generalize out of distribution. So I totally agree. I think this is a really big breakthrough. And yeah, the big thing that caught my eye for sure was that emergent skill evaluation, that 3x jump in capability.
Right. And even more to highlight that point, another interesting figure in the paper is actually across different labs, right? There's been various papers on various tasks like kitchen manipulation and cable routing. And it is worth noting that these tasks are still sort of tabletop tasks dealing with a few objects with kind of a static arm. So these are not moving around the house and making a sandwich for you or whatever. But there's this concrete result of, if you look at existing prior data sets and you have an existing prior approach, like, a more tailored approach from prior work, and you compare this general purpose model to this prior effort and data set, out of the box, RT1X does better than all of them by quite a bit. So that's another example of why that is generalizable and very cool. And the data and the models are released. And as you've seen, if you release a language model or ChatGPT or whatever, now a lot of research can build on top of that in various ways. And I would imagine that's going to happen with robotics. So really, really exciting news for robotics research.
Up next, we have decomposing language models into understandable components. This is really interesting if you're into interpretability and if you're into the kind of interpretability work that Anthropic does. This is a paper from Anthropic. It's part of their kind of series of papers and projects on what they call mechanistic interpretability. How do we understand the goings on within a neural network? How do we understand in human understandable ways what the network is doing, what it's thinking in some sense? And this paper emerges from a very clear and significant problem in interpretability. And that problem is that you can't pin down meaning to an individual neuron. So in other words, if you're never going to have like a single neuron that just fires when a sentence has been fed into a language model that involves cars. There's no car neuron. There's no airplane neuron, or there may be, but there quite often are neurons that or concepts that aren't represented with single neurons. So this is a huge problem if you're trying to understand the kind of thinking of a neural network for safety purposes, right? Trying to understand, is it making certain kinds of plans? Is it developing certain strategies or about to behave in a certain way? And this problem is known as polysemanticity. Basically, polysemanticity is the idea that a single neuron can fire for many different concepts. In fact, clusters of neurons can fire for many different concepts in different ways. And that's a real issue for interpretability. And so,
by the way, when we say 3 billion or 7 billion or all these numbers, that's a number of units or neurons in the neural net, right? So it's like a big muff function, and each little unit does its own thing, has some inputs and outputs, and somehow learns to process data. So there's a lot of units, and none of them do one thing. And that's sort of just by the nature of how our brains work and also neural nets work when you train them.
Exactly. Yeah. And just, to be explicit about that, right? Usually when we give the parameter count of a model, we're not giving the number of neurons per se, but we're giving like the number of, say, neuron connections, right? The connections between the different neurons. If you count them all up, that's the number of parameters, the number of things that you train during the training process to kind of refine. Exactly. And so essentially there's this problem that, hey, these systems, they seem to behave kind of like human neurons, right? There's no one neuron for, I guess, or I'm assuming, sorry, I'm talking out of my ass here. It's not like I'm a neuroscientist, but I'm guessing there's no car neuron in our brains either. And so what they're going to do is ask the question, okay, well, what if we zoom out just a little bit? We're no longer going to just look at the single neuron level, because that's hopeless. We've kind of established that. What if we find a technique that allows us to identify groups of neurons? If we do that, are we going to be able to resolve clusters of neurons that together seem to represent a well-defined human understandable concept? And it turns out the answer is yes. And the technique that they're going to use to obtain these representations, to identify these clusters of neurons, is called a sparse autoencoder. The details don't matter too much, but essentially what they're trying to do is train a model to just like take in the behavior, let's say, of the neurons at one layer of the network and just compress it and then reconstruct it from that compressed representation. And the hope is that that compressed representation can have properties that make it easier for us to kind of interpret the system. Going into more detail than that, I don't think is going to be helpful in this format, but that's just a rough idea of what they're doing. And it's remarkably effective. So they have a bunch of plots that show, that they get human annotators to go through and judge how interpretable different of these neuron clusters are. And they find just, a huge, huge difference. It's night and day. You really just have to look at these. The distribution is like shifted way over to the right, very clearly, huge, huge effect on interpretability. And that's a really big breakthrough, not one that I would have expected, to be honest, at this stage. And it also offers a way to steer the behavior of models, right? Because if you can figure out what the neurons are that fire for a given concept, hey, maybe you can make them artificially fire. And if you can make them artificially fire, maybe you can cause the model to display certain behaviors in predictable ways. And that starts to shade into alignment. It starts to shade into, catastrophic risk mitigation and all those things. And so really, really interesting, very consistent with the Anthropic mechanistic interpretability agenda. And I think a really exciting next step in their journey.
Yes. And again, this is really cool, right? So to give some concrete examples, they can find sort of a cluster of neurons. And as you said, just to self-correct, the number of parameters isn't the number of neurons, but it's correlated. So they find collections of neurons that, for instance, focus on legal language or DNA sequencing or numbers separated by commas or sports and things like that, right? And to give a concrete example, which is very cool, they show that if you feed in 1, 2, 3, 4, 5, 6, 7, 8, whatever, a normal language model will just continue with some more numbers. But if you kind of hard code some neurons to be active, to output, big numbers, you can steer it to produce other output. So if you have some neurons for Chinese, if you activate those, it will take the numbers and convert them to Chinese. If you have neurons for hexadecimal numbers, it will produce hexadecimal things. If you have a DNA thing, it will output DNA. So you can basically force it to produce different types of output. And this is very interesting in terms of what sorts of things you can do. Immediately, I have to ask, if there is a swearing set of units, right, of inappropriate units, can you just disable those? If they're sex or inappropriate concept units, can you just make it not talk about inappropriate things? Potentially, this is huge if, in fact, it's that powerful. So very cool results. As usual, the actual paper is super long. It's you can look into it on Anthropic, so we can't cover a lot of the details, but it's really cool. And you can actually look more into a lot of the examples in these interactive sort of tools they have embedded. So if you do feel like exploring more kind of what kinds of groups of units there are, you can click on the link in the description and go take a look. And on to the lightning round. First, we have Promptbreeder, self-referential self-improvement via prompt evolution. We've covered a few kind of similar types of works about this, where essentially instead of manually improving and crafting a prompt to get the output you want, you have some sort of algorithm that can do it. And so this is an example of that uses evolutionary training or optimization, where you start with a collection of prompts and then you basically mix and match and mutate them until you find something that works better. That's pretty much the summary, and it does, I guess, again, feed into a pretty substantial amount of work that has shown that we can actually make the inputs to language models more optimized without human involvement, which could be a big part of how they're used in practice in the future.
Yeah, and this is, when people talk about the singularity, right, and talk about AI systems improving themselves, and how that should lead to AI systems being even better at improving themselves, which should lead AI systems to be even better at improving themselves, and so on and so forth. Research like this is really kind of as close to that kind of research as we can do right now. The main problem with you might think, oh, well, why don't I get an AI to like look at its own neurons and try to optimize those directly? Well, there are just so many neurons that there's just not the computational capacity. Essentially, there's not the learning capacity to have that system learn how to kind of iterate on itself in this way. And it's also just like when you start to think about how you would execute on that, it gets very, I don't know, technically complex. This is, I think, pretty remarkable in terms of the originality of the particular mechanism they're using here. So they construct these prompts using essentially like one prompt or one type of prompt that's meant to generate new prompts. So the whole purpose of this prompt is just to like generate candidate prompts that then can be tested to see if they actually deliver better behavior than previously tested prompts. And those generator prompts themselves get mutated and tested on. So they have little kind of mutation functions that get introduced. And so this is where the self-referential self-improvement thing comes in. Not only is it running this experiment, this genetic experiment, if you will, trying to like iterate through different prompts and see what the best one is, it's also iterating on the mechanism that is generating those prompts. So it's sort of reflexive in that sense, or not quite recursive, but very kind of self-referencing. So really quite interesting. I think it's also, there's been some research that suggests that maybe prompting is mathematically quite analogous to fine tuning. And if that's true, then this process may actually be more like a system modifying its own weights, a system modifying its own parameters than might immediately appear to be the case. So if that's the case, I mean, anyway, this is a really interesting piece of work, very simple idea, very elegant. Would expect nothing less from Tim Hochtaschel, who led the project. He's been really interested in this kind of work, and he's done some interesting RL stuff too in the past. So very, very impressive result, and pretty jarring if you're looking at the prospect of or the risks that might come with self-improving AI systems.
Right. Interestingly, there was also a paper just 1 month ago, pretty much, concurrent work called Large Language Models as Optimizers. So similar idea there, not quite the same, but related. One caveat to all these things, which is true also with, for example, reinforcement learning, which is another mechanism by which you can self-improve, is that it relies on having an external kind of metric that you can evaluate yourself. And often, if you don't know how to do a task, you may not have anyone tell you, oh, you did good or bad, et cetera. So the example tasks here are relatively simple, like classifying whether something is good or bad. But I don't know. Yeah, it's definitely in an emerging line of work of understanding prompts much more. And, some people are saying, is academia relevant anymore, given you need compute for everything? And then you look at stuff like this, where clearly pure research still is very important.
That's a really good point. And next we have China's first 28 nanometer lithography tool to be delivered this year. Try saying 28 nanometer lithography tool 3 times fast. Anyway, so this is a really interesting story. I mean, I'm trying to kind of bring in some context here on the hardware piece, because we've gotten some feedback about that, that people are interested in that dimension. Let us know if that's not the case. But just to kind of put this in perspective, so we talked, I think, a couple episodes back about how there's this hierarchy of resolution in the chip making process. The highest resolution chips in the world are made at TSMC. They're 3 nanometer chips. So essentially, these have features that you need 3 nanometer resolution to create, and those all go to the iPhone. Next level up is 5 nanometers. We talked about that. That's the NVIDIA H100, and then there's 7 nanometers, the NVIDIA A100. Okay, those all require a special kind of device called an extreme UV lithography machine. Those devices are only manufactured by a Dutch company called ASML. So way, way above that is the 28 nanometer process. Essentially, you can imagine we need lithography machines that can make 28 nanometer chips. These are going to be much less advanced than the lithography machines that allow us to make to make 3 nanometer chips or 5 or 7 nanometer chips. They're much more clunky. Still, though, it's impressive that China managed to make a breakthrough, it seems, at this level, to build their own essentially homegrown lithography machine, essentially a device that fires a kind of laser insanely high resolution, in this case at 28 nanometers, so far from the cutting edge, but it's more about the story of China starting to domesticate bring home a full functioning supply chain for not just making chips, but making the machines that make chips, these lithography machines. And so that's what Shanghai Microelectronics Equipment, this company SME as it's sometimes called, has just pulled off. This is another big breakthrough, like pretty impressive. Previously, the best they had was a 90 nanometer machine. So that's a lot clunkier. So they're definitely making progress, and the kind of thing that you start to look at, when you think about policy, like what should we be exporting to China? What could we do to interfere with further progress as they now climb down? I mean, the next level below 28 nanometers probably is a 14 nanometer type process, I would guess, or something in that orbit, and that you're starting to get just one iteration above of the NVIDIA A100 level. So pretty impressive. It's the continued march of China trying to figure out how they can domesticate this very complex supply chain for making advanced chips.
Right. There are actually export regulations from the US, Netherlands, Japan, and Taiwan. So it affects quite a few countries, not just the US, as we often talk about. And yeah, I think we'll actually talk more about the policy implications in the policy section. But to finish up a couple more research works, like I said, we have a lot this week. We have an article, LLMs can't self-correct in reasoning tasks. DeepMind study finds. This is about the paper. Large language models cannot self-correct reasoning yet. And this is about this idea of self-correction that has been established in prior work, where essentially you have a language model generate some answer to some question, and then you tell it, review your previous answer and find problems with it. And then you tell it, based on the problems you found, improve your answer. And this was, kind of explored as a possible way to make LLMs work better for things like reasoning or, math problems or various things that aren't just, let's say, answering a question or something. And yeah, so this paper explored that technique more deeply and found that in general, it often doesn't work when you don't tell the model kind of why or how you got things wrong. Pretty much, yeah. So most of the time it doesn't work, and it seems like we need what they found is you need external sources of knowledge to check against, for instance, retrieval or web search. So good insights, useful for working with language models.
Yeah, I'm always intrigued by that last word in the title. Large language models cannot self-correct reasoning yet. And the implication there, if you're wondering about like what the yet is getting at, usually when you see that, it implies at this level of scale, right? Or with current techniques, but a big part of it is at this level of scale. And so we've seen this a lot where emergent capabilities just pop up when you scale up more. It may be the case or it may not be the case with language models that the self-correction thing shows up. Maybe there is something fundamental about the model's access to information. It can't reason better with if you prompt it without prompting it with new information that it didn't have at its fingertips, so to speak. So that could be a fundamental thing, or it could not be. And I think that's the implication, at least of this title, is they are not sure that it is a fundamental thing, and that perhaps with some fairly straightforward advances, this could be fixed. But yeah, the external database is one quick and dirty way to fix this sort of thing. But it points to just like the complexity, the challenge of even assessing where we're at with these systems, right? It's like, how close are we to human level intelligence? Like really, really hard to know. The failure modes of these systems are so alien. Like they fail in ways that human children just don't fail. on their way to adult human intelligence. And so it's really difficult to like look at these things and say, oh, we are here versus not here or whatever. So a really interesting entry. And I think what's shaping up to be a very important debate on just the current status and promise of large language models.
And to cover just one more paper before we move on, we have fine-tuning aligned language models compromises safety even when users do not intend to. So this is very much about the topic of if you release a language model that is aligned, so you kind of train it to not do bad things, broadly speaking, this paper shows that it's very cheap and very easy to do a little bit more training and undo all that alignment. And even more interestingly, if you just train it for some task that you just train it on some more data unrelated to alignment on safe or not, like you train it to know about very esoteric topics or something, you like know the language of Star Trek or something, it still degrades its ability to be aligned and safe. So yeah, this has pretty significant implications on whether you should release models that are aligned, because effectively, if you release the weights and give the ability to train, alignment doesn't matter. It doesn't really mean the model is safe.
Yeah, and this is so interesting. It seems like an instance of like catastrophic forgetting, right? That I think we've talked about this before, but anyway, basically this concept, this very concept, right? If you take a model and you've trained it to understand some stuff, and then you fine tune it on something else, it will in that process often forget some of the stuff that it once knew, and that's just because it's hard to rejig those weights, those parameter values, without losing some of the knowledge that was encoded in them previously through training. And so, yeah, I mean, I think this is kind of an instance of that. It also suggests that like there seems to be implicitly a kind of hierarchy, right? To like what knowledge and behaviors are embedded and at what level in these language models, right? Like it seems like the alignment piece really is received by the model at a lower level of depth than the actual knowledge of like how to write offensive outputs and things like that. And that correspondingly, it's that much easier to like get rid of the alignment by jailbreaking or just like fine tuning the guardrails out. They were saying, so this fascinating sentence in the abstract. They say, for instance, we jailbreak GPT 3.5's turbo. Geez, let me try that again. We jailbreak GPT 3.5 Turbo's safety guardrails by fine-tuning it on only 10 examples at a cost of less than 20 cents via OpenAI's APIs. And so, just showing how much leverage you can get out of just the wrong kind of training, so to speak.
Yeah, and they also mentioned, with regards to that, GPT 3.5 isn't open source, but they do have the capability to fine-tune and make your own version of a model, via the web. So one of the safety kind of mechanisms you can imagine is if you provide access just via an API, you can sort of control what people are doing and make sure they don't do anything bad. But if you can fine-tune it and very easily undo the safety safeguards, maybe even not obviously, that has some important implications. And this paper does discuss them. They discuss how most of the discussion about regulation has been focused about the sort of pre-deployment licensing and testing, where you show your model is safe or not. But if you can just change the model and make it not safe, all of that kind of goes out the window, or at least partially does. So some important questions introduced by these results.
Up next, we have our policy and safety section, and we start with RISC-V technology emerges as battleground in US-China tech war. And we haven't really talked about RISC on this. Well, we've talked about RISC with a K. We haven't talked about RISC with a C, and that's what this is. So RISC, so RISC-V, that's how you write it, but you pronounce it RISC-V. This is an open source technology. And it's essentially what it does is it serves as an interface between the hardware of like a semiconductor chip and the software that is actually going to give the chip instructions as to what to do. So RISC-V is what's known as an instruction set architecture. Basically, it's a library of functions that convert more sort of intuitive, human understandable code into like machine code that gets executed on the physical hardware on the microprocessor. So this is a pretty inglorious function. A lot of people don't know about this stage in the kind of life cycle of AI hardware, but it's really important. The big competitor right now to RISC-V, again, which is open source, is ARM Holdings. So ARM is this British company, and they do all their stuff in a proprietary way. They massively dominate the ISA, the instruction set architecture market for phones and for CPUs and things like that. And so RISC-V, though, is now starting to make real inroads. And there's this issue that it's a lot harder to regulate if it's open source. And in particular, China, which is looking for every opportunity to leapfrog the US or get into the kind of AI hardware game and generally just own as much of the stack as they can internally, they're turning to RISC-V as an open source alternative to ARM because it's harder to control. And that means that they can effectively skirt U.S. export control regulations and also, any regulation or any measures, let's say, that the U.S. government's in a position to impose on ARM. They can skirt around that just by using this open source software, this open source, I should say, ISA, this instruction set architecture. And so you've got a bunch of lawmakers in the U.S. Really worried about the loophole that this creates. So we've had Senator Marco Rubio, and then Mark Warner, who's a Democrat. Rubio's a Republican, Warner's a Democrat, so kind of bipartisan. They're both urging the Biden administration to look at RISC-V and saying, look, we have a national security issue here to the extent that we think that it is a national security risk for China to have a homegrown kind of supply chain for these more advanced chips. We have to start to think about these instruction set architecture elements as being a key part of our national security strategy and preventing choking off access to those systems to Beijing. So ironically, the funny thing about this is that originally RISC-V was research on RISC-V was like, I think it was spearheaded by like the U.S., maybe DARPA and things like that. So this is really, if I'm getting that right, I'm pretty sure that's what happened. This is sort of an ironic twist, unfortunately, for the U.S. in this whole story.
Right, and it again to highlight how significant this chip conflict, so to speak, is, right? All of that is deeply related to AI because chips and hardware are so essential to AI. And there's many dimensions, many things going on with, advancing technology and access to technologies, export controls, all of that. So that's why we've been talking about it so much. And that's why we probably will make a special episode just to delve specifically into it because it's such a rich topic.
Yeah. And actually, sorry, just a last quick note on the specific measures that they're looking at. So there's Mike Gallagher, who's the chairman of the House Select Committee on China, said the Commerce Department needs to, quote, require any American person or company to receive an export license prior to engaging with the People's Republic of China, with entities in China on RISC-V technology. So any kind of collaboration or partnership there is kind of coming into focus. So it'll be interesting to see if that makes a difference, if it's how much leverage there is in that particular part of the stack.
And on to the next story, also related to lawmakers. Meta and X questioned by lawmakers over lack of rules against AI-generated political deepfakes. So 2 Democratic members of Congress sent a letter expressing concerns about the emergence of AI-generated political ads and asking for explanations of any rules being crafted to curb the harms of free and fair elections. There is a lot of precedent for this, where Meta in particular and also Twitter have had special measures to prevent political misinformation, especially in the context of elections. And this is a new dimension of it that is quite important. Google has already announced that it will impose new labels on deceptive AI-generated political advertisements, but it seems that Meta and X have not responded to requests for comments. So yet another sort of concern, really, and one of these things where this is one of the safety implications of AI. As you get better and better generation of images and videos, you will expect more and more misinformation. And clearly elections is one of these things where misinformation can have a big impact.
Yeah, and obviously the looming 2024 election is looming large in a lot of people's minds. And what are we going to see there? There was famously a Republican political ad that was AI generated that kind of is at the center of a lot of the discussion around this stuff. I think one really interesting little detail. So Amy Klobuchar, who's a senator, in the U.S. Senate. She referred to this idea that one of the proposals that's been floated is that companies should be required to add notices that campaign ads contain AI-generated content. And she was referring to that requirement and saying, well, look, that's like the bare minimum. Like basically, we need to see quite a bit more than that. I think it's interesting that she seems to be pushing like the idea that we need even more regulation than necessarily is being suggested at the early stages here, in a context where she is also co-sponsoring another bill that is being referred to as the light touch bill on AI regulation, where companies would be responsible for just self-evaluating on, we talked about this bill, I think, last episode, but self-evaluating when it comes to the kind of ethics and safety and so on of their models. And so it's sort of interesting to see her apply this nuance. For some reason, she's very kind of pushing for more regulation on this one, maybe a lighter touch on some other things. I don't know. As much as I may agree or disagree with different things here, it's just nice to see somebody who's approaching this maybe with some nuance, if that is in fact what's happening. But just anyway, she's clearly drawing some kind of finer line here than is immediately obvious in the context of the article.
Right. Yes. The bill is actually going to ban materially deceptive deepfakes related to the federal candidates. And in fact, there was already an ad aired by the Republican National Committee that made use of AI-generated photos. It sort of portrayed the hypothetical future of the U.S. if President Biden was reelected with various bad things, and that may be banned under this rule. So we'll see. But again, deepfakes is one of these perpetual topics in AI, and as the tech keeps getting better and better, we'll probably keep talking about it more and more.
And now moving on to our lightning round, and we're actually going to open this with a story that was brought to my attention by, I think I mentioned him earlier today, Mike Justice. I hope I'm saying your last name right there, Justice. Sorry, Mike rather. So Mike is a lawyer at a law firm called Katten, Katten. Anyway, he was flagging this write-up that he'd done, which I found really interesting, looking at one of the bellwether AI copyright cases that's come out. It's called 5 Takeaways from Bellwether AI Copyright Case. And this is a case of Thomson Reuters versus Ross Intelligence. And it's the first summary judgment that we have that looks at fair use of copyrighted material to train generative AI models. And so it kind of gives us an early glimpse into how the legal system is starting, how judges are starting to think about, what does it mean to infringe on copyright in this context? And anyway, there were a couple of big take-homes. This whole case, by the way, revolves around the allegedly unauthorized use of content from Thomson Reuters' legal research database. They have this database of legal research, and supposedly Ross trained their generative AI model on that data. And there's this concern that now is that bot going to be spitting out copyrighted material? And I think it's kind of interesting, by the way, that this case doesn't involve OpenAI. It's like one of the first ones that's approaching the finish line, and yet it's not an OpenAI case. I personally find that sort of surprising, just because of how ahead of things. But poor Ross Intelligence is finding itself in the hot seat now. There were a couple of interesting take homes here. Essentially, one is okay, we don't have a conclusion, by the way, but the judge laid out the factors that would go into making a conclusion. And one of them is public benefit. And that's really unclear here. They're saying, look, we don't know yet how transformative this capability is going to be. Can the public use it for free? Does it discourage other creators by, as the article puts it, swallowing up their markets? In other words, are we really discouraging the creative act, which would be counterproductive to what the justice system is supposed to do? And so that public benefit piece is emerging as a really important pillar. There's also really interesting nuance introduced in terms of the difference between unprotectable facts and ideas, so facts and ideas that can't be copywritten, and protectable creative expression. And the argument that the judge was making was like, look, by and large, the more your content, the more the generated content differs from the original training data set, the safer you are from a copyright perspective. And so that's kind of intuitively makes sense. But anyway, it's interesting to see it enshrined here. And just the last thing that I'll flag is this concept. And Mike actually explained this to me when I spoke to him. But he was saying, look, there's this interesting debate over whether the language models are kind of memorizing essentially the text that they're reading. In which case, if they are memorizing that text and they can recite it verbatim, does that not imply that they copied it? That they truly copied the text that they're reading? And the argument apparently is that this is actually okay. It's often okay to replicate even copyrighted material as long as that replication is just an intermediate step on the way to producing something original. And I can't exactly remember it, but Mike, when we spoke, he gave me this example of I think it was like somebody reverse engineering like a Sony or Atari game to figure out how to make new games that could plug into Sony hardware. And he was saying, look, as long as you don't directly commercialize your replica, you're fine. You just have to make sure that you're making kind of new stuff. So all these really interesting nuances that I hadn't realized were already this far along in the kind of legal debate process. And Ross Intelligence versus Thomson Reuters. It may not roll off the tongue, but it's definitely going to be an interesting legal case to follow.
The court indicated that a jury trial is set for May 2024, so not for a while. And as we've talked about, there are quite a few lawsuits against OpenAI that are dealing with a lot of the same topics. So probably in not too long, we'll be talking about a lot of legal stuff. And that'll be maybe a bit of a challenge given...
We'll do a legal special.
Yes. Our next story is that AI could soon need as much electricity as an entire country. So this is a peer-reviewed analysis that estimated that by 2027, AI servers could consume between 85 to 138 terawatt hours of electricity. That is similar to countries like Argentina, the Netherlands, or Sweden. And as this says, that's a lot of electricity, right? And that was going to stress out our infrastructures, I guess, as far as how much electricity we need to produce.
Yeah, about 0.5% of the world's current electricity use, apparently. So these are like really big numbers. It's no coincidence that every time you see a big data center build from Microsoft or Google or something like that, you will see at the same time some commitment to like green energy or whatever, and also interest from, I think we talked about this last time, Microsoft is showing interest in using small modular reactors, essentially small nuclear reactors to power their data centers. And this is really starting to become a major focus as when you zoom out, you start to realize more and more of humanity's energy production is being directed to performing computations, matrix multiplication math on these obscure but very, very important pieces of hardware, these GPUs and other kinds of chips. So it's sort of fascinating. We're like literally seeing in real time as humans offload our cognition to these systems, and basically you're seeing energy go from nuclear power plants to creating intelligence. And I think that's just so fascinating, even from the standpoint of the history of the universe. Like we're at the point where energy is being turned into intelligence. That's a like a physics thing that we're actually starting to do at planetary scale. It's pretty insane.
Yeah. If you look at what we already have in 2022, data centers for all computers, including Amazon and Google, used about 1 to 1.3% of the world's electricity. And apparently crypto used another 0.4%. So if AI catches up to 0.5 in just a few years, that's pretty crazy. And the reason that's realistic is there's this projection of how many chips NVIDIA could ship. It says that maybe, up to 1.5. Of course, these are still projections. And the thing is,
1.5 million, by the way.
1.5 million, right? And GPUs, we already have a ton, like the internet takes up a lot of compute, but these are CPUs typically. And AI stuff just takes a lot of compute with GPUs, so that results in more electricity, in more expense, and so we'll see, how it scales. The next story is government's race to regulate AI tools from Reuters, and this is pretty much just an overview of what a whole bunch of countries are doing. Australia, Britain, China, the EU, France, Italy, all of these countries have their own various ongoing efforts for regulation and other things. So we've discussed many of them. I don't think we need to go over the details here, but if you do want to sort of catch up on the state of regulation, in particular, especially in China and the EU, which have already, are doing some pretty dramatic things with these sorts of things, check this article out.
Yeah, I will say one of the things that they omitted from the article was any reference to Canada, because we actually have a bill called Bill C-27 that's going to be debated or that has been debated. It's being sent to committee right now in Parliament, and it's got the AI and Data Act, which I believe currently is the first piece of legislation I'm aware of in the world that actually introduces prison time for reckless deployment of AI systems, maybe reckless use as well. But it's a really interesting kind of precedent-setting piece of legislation potentially. And Canada not on the list. So maybe a little fun fact there if you end up reading the article.
Well, who cares about Canada?
Yeah, who gives a shit? Nobody cares. Ouch. All right, up next we have U.S. curbs on chip tools to China nearly finalized, government posting shows. So there's essentially way back on October 7th, 2022, so basically this time last year, the U.S. introduced a bunch of export control restrictions for chip making tools that kind of apply to U.S. industry, and NVIDIA has been a really big receiver, let's say, of these restrictions. That's forced them to design new kinds of GPUs, the NVIDIA A800 instead of their A100, and their H800 instead of their H100. And one of the really kind of key aspects of those export controls has been that they're concerned with like the interconnect bandwidth between these chips. So, there are operations that you do on these chips that involve matrix multiplications, and it's very easy to send those operations to different chips to have them do them in parallel. And that's great. But then at some point, you got to pool that stuff back together to kind of continue with your training process. And that pooling stage requires communication between the chips. And it turns out to be a bottleneck. And for a while, U.S. export control, actually currently, I believe, U.S. export control rules rely on that bottleneck. They say, look, you're not allowed to have an interconnect bandwidth that's above, I think it's 600 gigabytes per second. So that's an interesting constraint, but unfortunately, and this is based on the analysis we've done at Gladstone and talking to some of the top AI hardware specialists that we deal with, it just turns out not to be like an effective constraint. And that's because it turns out that you can just get around it by using more GPUs. And according to the experts that we work with, it just introduces like a 30% tax on your GPU pool. So the idea is like you need just 30% more GPUs to train an equivalent model if your interconnect is capped in the way US rules currently require for for GPUs sent to China. And so the reality is, if you're China and you've made it a national strategic policy priority to train frontier models, like a 30% tax it doesn't matter. It doesn't even register. And so, by this analysis, if you buy into that, then NVIDIA is sending very powerful GPUs to China in a context where, as far as I can tell from the information I've seen and the folks I've talked to, these GPUs may well be capable of supporting GPT-4 and even GPT-5 level training runs with all the national security implications that come with that. But it actually gets somewhat worse too, because at this point, looking at the current environment, a reasonable person would probably expect that stronger export controls are on the way. And if NVIDIA thinks that, if they think that's the case, then they face incentives to ship as many GPUs to China as they possibly can while their window is open. Right? So the risk is that NVIDIA has this incredible incentive to not only ship potentially dangerous hardware to China, but to preferentially ship that hardware to China in order to get as much out of that market as they can before the export control window closes. And so for context, actually, as it stands, and this is just based on public information, NVIDIA has committed to ship 100,000 GPUs to various Chinese companies. That's just in the second half of this year, of 2023. If you think about it, that is 4,000 GPUs per week this year. And based on other public orders that we're aware of, if you're looking at 2024, that's about 10,000 GPUs per week that NVIDIA will be shipping during all of 2024. So we go from 4,000 per week in the second half of 2023 to 10,000 per week during all of 2024. And probably those 2024 ones are going to be, the H800s, not the A800s. We're looking at not only more, but also much more powerful systems. So realistically, we're kind of going to be shipping, right now, we're shipping about one GPT-4 equivalent of compute every 4 weeks to China now. And if my math is right, that's going to go up to well over one GPT-4 equivalent every week in 2024. And that's just based on, only a couple of orders that were published in the news. So this is probably a minimum estimate. So anyway, as so many politicians and analysts are saying, if you think of GPUs as the fissile material of AI, then you could absolutely argue that what we're doing here is kind of arming our adversary. And that's why there's so much interest in tightening up these loopholes. And we'll have to see if that's what ends up happening. But at least right now, it seems to be in the cards, at least based on the story.
Right. As they pass, if you need to smuggle money into China, soon enough, it might be that you just want to smuggle GPUs.
GPUs, that's the way to do it.
Right. On to our last section, synthetic media and art. The first story is WGA ratifies 3-year deal with studios ending Hollywood strikes. So we've been covering this. The Writers Guild of America has been on strike for months, with part of the discussion being around AI. And the request was that AI cannot write or rewrite literary material, can't be used as source material, MBA covered material can't be used to train AI, and these sorts of things. So now that strike has come to an end, there is now a deal. And as we discussed, I think maybe last episode, on the AI front, the deal actually does include a lot of what they wanted, that AI cannot be listed as a co-author, for instance, cannot be credited as an author, which has implications for wages and things like that. So yeah, it's pretty important to be aware of, because as kind of the first really large-scale strike and labor effort to make kind of, I guess, restrictions on AI in a particular professional sector, this may be setting a bit of a precedent, and I would not be surprised if we will see something similar for actors who are currently on strike and potentially other labor sectors in the future.
Yeah, that's a really good point. The SAG strike is like Screen Actors Guild strike is. I'm confused about where we are in that process, but it seems like it's advancing and kind of similar things. Yeah, I mean, hugely precedent setting and just weird. In retrospect, I remember back in like 2015, people were saying like, oh well, the artists are going to be the last ones to get automated away or to face pressure from automation, and I feel for these folks because it's like it really does seem to be the first thing to go, and interesting that they find themselves in this position. Yeah, we'll be tracking the SAG strike and negotiation process, I'm sure, in future episodes as well.
Moving on, we have AI watermarks are no match for attackers. So we've talking about watermarks for quite a bit. The idea of watermarks is you can basically place some sort of invisible code or invisible, signal inside an image or text that allows you to verify whether it was AI generated or not. And so researchers have demonstrated that attackers can remove watermarks from AI generated images and even add watermarks to human generated images, basically meaning that for now, this is not very kind of safe to assume that we could watermark AI generated images to be able to tell if something is a deepfake or not.
Yeah, and it's all part of this question, this eternal question, it seems, about whether the offense or defense side is going to win out when it comes to AI generated stuff, images and text. And I think we've talked about this in the past, but my suspicion is in the long run, it becomes really impossible to detect these things just because the generation models become so good at replicating the statistical patterns that exist in real world data that it's just like, we're already seeing it with text where you need really long strings of text before you have any real shot at detecting stuff. But watermarking is an interesting way to kind of break through that. Maybe you can embed artificially things in your images, but then there's going to be the whole watermarking removal game plan. And that's kind of part of what we're seeing here is people finding ways around that. So interesting, but we'll see if watermarking will survive the test of time.
Right. The paper is actually titled Invisible Image Watermarks Are Provably Removable Using Generative AI. So pretty strong results. And basically, the idea is you add some noise to the image and you reconstruct it, but just without the watermark. So it's a very general technique as well. So we'll see. And in fact, related to that, this is kind of a research front, but also very related to the topic of synthetic media. Stable Signature, a new method for watermarking images created by open source generative AI. This is from Facebook AI Research and INRIA, and this is a new method for watermarking images. It's invisible to the naked eye, but can be detected by algorithms. It's robust to cropping, compressing, and changing colors, but probably not robust to the thing we just discussed. So I guess it's good that we have these, because if you do have Adobe or someone providing a service, unless you have an attacker trying to fool you, if it's just like someone posting something on Twitter, then these watermarks will actually be very useful.
And that's a really good point. I mean, I think there's a truism in safety, in security, where people say, look, it's not a matter of achieving perfect security. That's never going to happen. You're trying to make it that much harder for people to do it cheaply, and that does make a difference. Though it is like slightly funny that these poor Facebook AI researchers had to publish their paper at the same time or the same week, roughly, as like the proof that watermarks don't work. So
the paper is actually like 2 months old, but the article came out at a humorously similar timing. Yeah.
Well, so they were able to celebrate a little bit at least.
Yeah. And on to the lightning round with just a couple stories. The first one is how an AI deepfake ad of Mr. Beast ended up on TikTok. So this was a very kind of widely discussed example of deepfakes. Mr. Beast, a very famous YouTuber, had a deepfake of him be on TikTok offering viewers an iPhone 15 Pro for $2. And this is a scam, right? We'll see a lot of these. And it slipped past the moderation technology that should prevent deep fakes. It was removed within a few hours for violating its advertising policy, but it's yet another example of a high-profile celebrity being deepfaked to do something.
Do they say how many? I'm going through the article right now. I don't see a reference to how many people specifically had seen it by the time it was taken down. I mean, it's TikTok, so my guess is the damage was kind of done.
Yeah, I'm not seeing that, but it's probably safe to say it
A lot.
got seen. Yes.
Yeah, I mean, just wild, and it's surprising too. Like, you know, you'd think, I don't know, I guess you'd think that it'd be possible for automatic content moderation tools now to pick up stuff like this, but you know, maybe it's not necessarily as obvious what makes something scammy. You know, maybe that's a harder thing to train into these systems. But hopefully, this will serve as a good training example for the for like some automated scam detection technology.
Right. You can go to the article and actually see the video that was reposted on Twitter. And as you might imagine, it's just looking at it, it's not clear that it's AI. It's just that good now. If you just do face swap or even voice synthesis, you can make it so that people can't really tell. So now you need your skepticism sensor to be pretty high up, right? We all do, I suppose.
Yeah.
And for our last story, Disney's Loki faces backlash over reported use of generative AI. So this is about a poster that got released for the TV show Loki for its season 2. And some internet sleuths looked at the poster and in particular the background image and found some aspects of it that looked like it was AI generated. Some sort of like weird little artifacts and pointless pixels and warping and things like that you generally do see with text to image models. Interestingly, what actually got revealed is that this image was from Shutterstock. So it's not that the creators of the poster used text to image, rather they paid for it as a stock image, and it wasn't labeled as being AI generated. And Shutterstock says that it's against their policy to post things and not make it clear that this is AI generated. So an interesting example of how you will have controversy if you use AI in your promotional material. Disney has already gotten in trouble for this with another TV show, and also how people may accidentally use AI generated stuff and, get found out, I guess.
Yeah. I mean, it's sort of funny to think about that hot potato getting passed, from Disney then onto Shutterstock all of a sudden when the story just pivots and you're like, oh, wait a minute, like actually Shutterstock seems to be kind of violating their terms and conditions. This, very interesting, and shows you the kind of sleuthing too that you have to get up to, the sorts of artifacts that you have to look out for. We've talked about these on the show before a lot, but like you can see here kind of like the Roman numerals, they don't make sense. There's this kind of clock-like shape in the background of the poster here. And then they're just kind of numbers that are cut off in weird ways. And anyway, a 4 that's got like, with Roman numerals, you don't write like 4 lines. You write a 1 and then a V for 4. And here they have 4 lines, and so it's kind of that sort of weirdness, right? So sort of interesting. Like you can actually see the logic in the error there, which is kind of interesting as an artifact, but still too bad for Shutterstock.
Don't think Chris was using DALL-E 3.
That's right. Did he use DALL-E 3?
Well, with that, we are finished. Thank you so much for listening to this week's episode of Last Week in AI. Once again, you can find the articles we discussed at lastweekin.ai. Please share and rate the podcast if you are a fan, but most of all, please do keep listening.